So hello everyone, thanks for being here. I wanted to start saying that sometimes when you sum up like little incrementals or iterations or differentials, if you will, you can achieve like bigger things by these little steps, these little iterations. And these little iterations, they can have a greater area under the curve that this, at the end of the day, could be, for example, building a feature. And when you do these small steps, you can get feedback sooner from people, from these iterations. So my name is William, and I want today to introduce you to two different problems that I get from you. I work at GitLab, and after the first presentation, I remember I got a lot of feedback and questions from different people, and I had different consultations. And I was listening to this feedback, and I could see it. And also, I had an opportunity in a real-life implementation where I could see that we ran short of time in the previous presentation, and I wanted to address today two specific things that were not necessarily covered in the previous one. So if you will, this is the episode 2. You can think of Attack of the Clones, or better, the Godfather 2, because we are talking about deploy like a boss. So the Godfather sounds more suitable. So I listened to your feedback, and based on that, I wanted to show and share with you how we can scale and we can do more things building on top of our previous episode. So if you like sticky notes and you miss these meetings on Sprint, we can say that we already fixed or we solved the problem of automating our virtual assistant, automating the life cycle of it. And just a quick refresher, we can say that we automated it by using this orchestrator pipeline that is a multi-project pipeline that I was triggering, that was building different projects and going through different stages, like building the image of the bot, then pulling training data from different sources and validating that the data was okay. And this was calling another pipeline that was training building the custom image for the custom actions and checking for code quality, security, code coverage, and deploying to production. And this one that was converting the data was at the end finishing in that we were calling the Rasa project, building the bot, testing the bot, training the model, testing the model, and deploying to production. So this is what I would like to say that we solved in this automate the virtual assistant lifecycle. And now the projects the problems that we want to solve that are better problems is how can we scale this DevOps workflow, and how can we add version control for the models and data. So this is the two things that we will explore today. And I like to say that we have two better problems. And why better? Because this, I don't remember where I read it, but you can think that a homeless person, they have money problems, they have issues, they have financial problems. And Jeff Bezos, he also has financial problems, but his financial problems are better than the homeless one. So if you made it this far, that you already automated your pipelines, that you have a virtual assistant with several steps that you can take from Git commit, Git push, and deploy to production. And now your problem is that some of the pipelines are long-running pipelines, that they are slow. That's good. It means that there is this little incremental I was talking about in the beginning, in the introduction of my presentation. So problem one that I will address in this one is what can we do when we have long-running pipelines? And second, it was inspired by a real-life implementation, and later I saw it in one of our Slack channels, is that there is a need in machine learning applications that you need to do version control of the code, but you also need to do version control of the data sets and models. And this can be large files that they are not suitable for Git. So we need to do these two things. We have data and code, and we need version control for data and code. So how can we do this in a DevOps platform way? So when the model is too big, it's not suitable for Git, how can I solve that? Or when my training data is too big. It can happen that is too big, and if not, because the YAML file, let's say that is not that a problem, the architecture that I will show you today, it enables machine learning applications, in this case, our Rasa virtual assistant, to scale and and it's easier to share the training data with other people. For example, in my data registry architecture, I have a folder for training data in Spanish and training data in English, and you can easily share this and someone can pull the data and you don't have to clone the repository or share files with the training data separately. So again, taking it back from our previous presentation, from our previous episode, the gap between the idea and the real users is full of reality checks. And one of those that I want to address today is that what can I do when my pipeline is running for too long? And what can I do when I need to also have version control of the data? So the question we answered last time, or at least my answer was like, how can we automate and deliver faster? And here we want to say, how can I automate? How can I scale and deliver faster? My answer to these two questions, like business-like answer, use a GPU runner and use something that you can track code, models, and data sets. Easy. So now go implement it. So these are the two things that I will show you how we can use in a DevOps platform. And again, I wanted to extend from the previous benefits that we mentioned that when you do this and you make your life easier, the life of the conversation designer, the developer, the machine learning engineer, the data scientist, the project manager, everyone that is involved in a project, you can focus better. You can focus on improving the bot. You can train, test, review, and deploy faster. And I wanted to highlight that you can scale and extend the Rasa project architecture. In this case, the architecture of today is different than the one that we saw last time. It's different, and I extended it with this additional component to track models and data sets. Again, kudos to our good friends, the command line, these commands that we heavily use in the pipelines. And I will introduce to you I don't know if it's technically correct, but it's sticky, the Git for data and code machine learning workflow. So this is the architecture that I wanted to discuss and share with you today. This is based on real life and also based on the feedback that I received from you. So you can imagine that you are a person, that you have your local project where what you did is that you initialize your Git repository, and then you did Git init, then you did Rasa init. So you have the initial template for Rasa project, and you also initialize DVC. You do DVC init, so init everything. So one of the things that you need to make sure is that when you create a git ignore file, in this case, we want to ignore the file, this folder where the data is for this specific use case. If you also want to ignore the models, you will add models to this git ignore file. And the workflow is that someone can work enhancing the training data of your bot, but every time that this person is adding something and is pushing these changes, he's not pushing it to your GitLab repository because that's what we don't want. We don't want Git with large files. What we do is that we push it to something called DVC. As per DVC documentation, they call it data registry. That is another project that keeps track of the changes in your training data or in your data sets, and they call it and they get involved. They get called from a remote storage. So this remote storage can be Google Drive, it could be S3 or any storage in the cloud. So what you do is that you ignore from Rasa project the data folder and all the changes to the data, the training data, you will push them to this data registry. And when you make a change to your bot in the remote, when you make a change in the code of your bot, you change the config file or you change the code of the custom action, this will trigger the pipeline that the pipeline that we mentioned in the previous episode, that it will build the bot, it will take the Docker file and it will build the image. And very important, and this part is very important, it will train the model. And this is addressing the second part, the second problem we were talking about. Because when I train the model here, I am bringing the data from the data registry. I am pulling the data from the data registry, from this step, from the training step in my pipeline. And then I follow all the traditional steps that you probably are familiar, and it will end up in uploading the model to Rasa X server using their API. So how does it look like, and how do we start to solve this thing? So the first problem, how can we avoid, assuming that everything is correct and it's a computational resources thing, your problem, we can use dedicated runners that are also GPU enabled. So what does it mean? That you use these commands from your local environment, and let's say that you change custom actions and you change the training data, so it will build your image of the virtual assistant, the Rasa virtual assistant. But when it goes to the training step, it will spin up a machine, a dedicated runner that it contains, or it's enabled with a GPU, in this case an NVIDIA Tesla. And from this machine, from the GPU one, is that in the script we will do dvc get to call our training data. So we don't call the data directly from the original project, like when you do Rasa init, you have a folder for data. No, we will call it from a different machine that is GPU enabled, only this part, this folder that contains the training data, and we will train the model using this machine with the GPU. This is one way that you can do it, and I will show you in a very small example how does this look like. So this project here, going back to our architecture, to this architecture, we have the remote and we have the data registry. This project, the data registry, it contains different folders. And these different folders, you can think that they are different. You could use them for different training data, different data sets for different use cases. So you can have something in Spanish, you can have another data set for FAQ. And in this case, I am using this one that is using DVC, and it's telling DVC, this is what is doing all the version control of my data. Whenever I change something or I put something, this is what I know that I am doing, that the data file is under version control. This is the responsible part of that. So you can now, I invite you to think in different use cases where, imagine a situation in which there is a new department or a new team and they say, we would like to spin up a new bot and I want to train the model real quick. How can I do it? What you do is that you share this URL or this data registry repository, and let's assume that other team, this is a different project, they want to test a bot, and this virtual assistant is you can see here in the project, we don't have the data folder. We don't have it, we don't use it here. So what we do is that, let's check the famous pipeline, is that if we see one of the pipelines that I have previously executed, so let's see this one. This is just for illustration purposes. You can see here a POC, or a very small representation or illustration of the two problems that I introduced solved in one. When we build the image, we are using the Docker image, the Docker file for our bot, for our Rasa virtual assistant. And we can see that this was created by a shared runner. This is a machine that has very standard specs, hardware specs. But now that we created the image and we have the virtual assistant ready, we want to train it. And when we train it, we don't want to use a shared runner. We want to use something more powerful. And that's why this is a dedicated runner. That is, the way I know that I'm calling it is because I tell the CI pipeline that when it's about to execute the job, please call a dedicated runner that you will find, because I'm giving it this tag. And as you can see here, there are different things that are going on. First of all, this dedicated runner is being initialized with GPU enabled. So it means that when we run Rasa train, it will the TensorFlow library will find that there is a GPU available and will use it. So this is one thing. And second, I want you to see here that this part is the key part, where what we are doing is that the training data that we need to train the model, the chatbot model, in this stage, we are doing DVC get, and we are pulling it from the data registry. And this URL of this data registry that I'm highlighting here is this other project. So you can now quickly imagine another use case where someone, if you want, some team can be dedicated only to update the training data. And what you do when you want to share this training data is that you share the URL of the data registry of the GitLab repo in this case. And by using this command dvc get, we DVC get and giving it the folder where we have the data. This is pulling the training data from Rasa, and once it's here, we can see that now it can start training the model, and we are training we are running Rasa training, it's training the classifier, and it's using the GPU. So this, if we scale it and we compare it, this is faster. So this little project is illustrating the solution for our two problems. How can I avoid long-running pipelines? So as you could see, for this one, I am using a shared machine, custom hardware, standard hardware, and this one I have something more specialized. And this one here is basically this virtual machine that I have with GPU enabled. As you can see, this is the one that I'm calling. This is the one that I'm calling from my pipeline, and this is this machine that I created in Google Compute with GPU enabled is picking this job that requires GPU and trains the model. So this for illustration purposes, I just show you how you can solve two of the two problems that I introduced. So one of the things very important here is that when we start tracking data sets and models that are not suitable for Git, we can make the experiments more reproducible. You can share models. You can do all many of the things that you can do with Git. Now you can do with DVC by learning their commands. So a quick demo of what is DVC and kind of in action I want to show you is this little quick demo that I recorded here. That let's see here that this is the traditional data folder from Rasa. You probably are familiar with this. And I'm opening the NLU file. And this is the traditional, the one that gets created when you do Rasa init. And I'm adding another sample to the intent grid. Like, hey, yo, it means greeting. So I saved the changes. And in many cases, or what I was showing in the past, is that we were doing git push. In this case, we don't do git push. We do git add, and we add the data. We add this training, the training data from Rasa. We are adding it now to our remote, but in this case, our remote is the remote storage. So when I do the change to my file and I do DVC add data, now I push it. And just for illustration purposes, you can see here that now I did, like in Git, I did git add and git push, and I am pushing this data to the remote storage. And consider this part where I am going to delete the data folder. So as you can see here, I deleted the data folder, the folder that we use to train our Rasa chatbots. The folder is not here anymore, but now when I do DVC pull, this will go again to the data registry and will go to this remote storage, and it's bringing me the data folder. So the data folder is back here, and if I open the contents of it and we do a cat to the NLU YAML, you can see that it brought the change that we added, the hey yo extended. So this is what DVC does. I'm just scratching the surface. I invite you to read the documentation and find lots of other things that they have. But combined to what we can do, implementing it and integrating it with GitLab as a DevOps platform, in this case, when we run a pipeline like this one, that we can, let me show you the GitLab YAML, CI YAML file, very simple one, illustration purposes. What we do here is that in this training stage, we are getting the training data from this repository, from this data registry. And this is all what we do. So very easy to imagine, as I said before, that separate team can take care of the data registry, keep updated the training data or the data sets or models, and then you just call them from your jobs. And by using this stack GPU, I am ensuring that I am calling this GPU enabled machine. Simple. This is one way that I wanted to share with you in how to solve these two problems. So now, going back to our previous episode, when we were checking the deploying all together, my favorite orchestrator workflow. So you can see here, this was just one example of what we can do in kind of a MVC way, in a way to iterate and see if it's how doable it is. But when we come to the full-blown project, the chatbot agent that some of you are familiar with it, you can see here that I don't have the data folder here either. I deleted it. because I am pulling my training data from the data registry. And here in this pipeline is the pipeline that you are probably familiar, that we create the image, we test the image, and here again, we train the model. And in this training model, I'm using the GPU. And when everything it's okay, I can come to deployments, environments, and I can see that my bot was deployed to production with this from this merge request. And very nice also from DVC is that in the merge request, it also helps you to bring reports that get created after you, for example, run you get the results from the training in the testing, and the testing the NLU in Rasa, and all these reports by using DVC CML, that it stands for Continuous Machine Learning Integration, I think, you can bring all those reports and put them right in the merge request. So this is what is bringing software development practices into machine learning projects, because you don't really have to learn another tool. You don't have to bring another software. If there is a company that they have established development workflow, when they know what is a merge request, how to create an issue, how to collaborate in something, how to do code review, how to do a review before merging something and deploying to production. All of these tools like DVC along in a DevOps platform like this one is integrating into these already existing workflows in a way that enables different people to collaborate. So as you can see here, this is what we get from Rasa. I am putting it directly in the merge request. And if I go to monitoring and deployments, I can see the different environments that I have created for that. And when it gets deployed, it's something like this. Remember the previous demo, I have a client that I built where I want my bot to live. And this bot was just, I already asking a joke. So let's ask him for another joke. So tell me a joke again. So this trading is not gambling. Okay. That's funnier today than last time. Last time was something with Dogecoin. So again, this is what you get when you automate all of these things. And to finish my pipeline, there is one step in the pipeline that I deploy to production. And when I serve this model to production, what I'm doing is that I am deploying it to my Rasa X server and making it active. So as you can see here, this is one of the pipelines that I ran recently, that when I make a change and I run my pipeline, all of these steps will go. The difference that one step is using a dedicated runner with GPU, and the training data or the models are being handled and versioned by DVC. And all of these things happen similar to the previous one, and they make the model active and they upload it to Rasa X. So the different pipelines that you are familiar with, the two problems that I want to focus and show you how you can iterate and extend the previous one. The custom actions remains the same. We have simply you change the code in your custom action, git commit, git push, and this will build the image and put it into Rasa X server. And I wanted to close the presentation by saying that by doing this git data plus code, we can extend and scalable Rasa projects, and you can solve some of the issues like how can I reproduce this experiment because I want to use this specific model that I know is under this version control with this data. How can I bring it in an automatic fashion? So this is one way, and I wanted to reiterate in our previous conclusions is that by doing these type of things, you can automate and focus on learning from real conversation faster, because once you go through this learning curve and you implement this one time, then it will be easier. For me to make these changes from the episode 1 to the episode 2, it was real quick. I just had to edit my GitLab CI YAML file, change two things, create a data registry, and there you go. A better architecture, in my opinion, to scale the DevOps pipeline. And this, at the end of the day, will help us to deploy the virtual assistants and test the ideas faster. Because as I could see from real life, from some of you that reached out after the first presentation, it was a stopper when the training was taking too long and the runner was timing out. And that shouldn't be a showstopper if you use a GPU-enabled runner. So thank you, and we have time for a Q&A.